Look at almost any physical object around you, and you'll find it was likely born from one of two very different worlds: the ancient tradition of craftsmanship or the modern engine of digital mass production. This graph illustrates the trade-off we accept. On the left, a single artisan can build a beautiful, bespoke object, but output is slow and expensive. On the right, a factory line pumps out millions of identical units without a drop of individual character. These two disciplines also have clashing cultures. Makers and hackers tend to embrace a chaotic, fail early, fail often ethos. True engineering, on the other hand, demands strict, calculated discipline. So how do we bridge that gap? Is it possible to combine the tailored beauty of handmade craft with the strict precision of digital engineering in our everyday objects? Right now, physical hardware creation is bottlenecked because creators are usually forced to pick a lane. You either get to act as an artist or you act as an engineer, but there is an alternative model, the Tradgitial workshop. Here, the physical and digital collide, where gears, circuits, and code run wild together. The operating principle here is simple: innovation meets ingenuity. Having a wild conceptual idea is only half the battle. You also need the disciplined physical skills to actually pull it off. Instead of isolating different departments, mechanical design, electronics, and software development are synthesized entirely under one roof. From that central intersection, a project moves instantly from rapid digital prototyping straight into physical fabrication. Operating everything inside this tight Tradgitial pipeline allows a workshop to create unique, highly custom objects at a price point that actually competes with mass production. We don't have to guess if this hybrid approach works. Look at a company like Green Shoe Garage, an engineering firm based in Maryland that actively deploys these methods to solve real problems. Take their smart greenhouse project. By outfitting traditional agricultural structures with Arduino hardware and cloud-connected IoT sensors, they created an open-source system for smarter crop harvesting. Or look at their Tankful project. They took 2 standard water tanks and embedded them with custom sensor arrays, turning basic plumbing into an active data experimentation platform that debuted on the massive floor of the Consumer Electronics Show. Because the design software and the fabrication tools sit in the exact same room, this setup allows for rapid crisis response. During a global relief effort, they were able to instantly pivot and 3D print components for medical face shields to supply local healthcare workers. By collapsing the distance between a digital idea and a physical object, teams can quickly deploy working solutions across agriculture, data research, and emergency medicine. Building smart hardware today requires a unified understanding of both the physical environments we live in and the digital networks that surround us. That level of integration brings us to a crucial guiding principle for this new wave of creators: consequence-aware engineering. To practice consequence-aware engineering means designing technology that explicitly protects individual privacy while serving the greater good. If you are building an open-source environmental monitor for a bedroom or an office, you have to consider the ethical implications of putting a sensor in a private space. That reality dictates the shape of the physical hardware as well as the software licensing. To successfully build for the modern world, it takes a rare combination of skills. You have to work with a craftsman's hands, an artist's brain, a hacker's soul, and an engineer's heart.